everyone. Welcome to Scholarship Tracks live Q&A session based on Roadmap to Computer Vision. Today we have Puneet Sarvatas, who has been in the field for more than 3 years now and is currently working as a software engineer at Apple. Thank you so for joining us today.
You're welcome. Great to be here. I've seen some of
Okay,
the sessions that Scholarship Track does, and it's very exciting to be able to connect with the audience.
thank you, sir. Okay, so let me explain how will this go. In the first half, I'll be asking questions about his general questions about his preparation tips and strategy, and in the later half, we'll take up the questions from the audience.
Sure.
Okay, so let's begin. Okay, so my first question is, how has your journey been from a student in College of Engineering, Pune, to computer vision engineer at Apple?
Sure. I mean, it's been a long journey. I graduated around 5 years ago, so it's been a while. Um, I think we should start more before and say how did I even get interested in computer vision as a field? And it started very early in my undergrad years when in 2012, 2013, that was a time when one of my friends had visited a conference in the US. And there we learned about, or he learned about augmented reality. And so when they came back to university and they said, hey guys, there's this cool new tool available, we can do some augmented reality stuff. And he got in touch with that company to give us access to their tools. And so we had built a couple of augmented reality applications at the time. So this was like 2013, 2014. Me and my friends, we were building augmented reality applications already, just for fun. And we put some of them on the BlackBerry App Store because that was, me and my friends were working on BlackBerry apps at the time. So we built an app where you can like point your phone up and it will show you nearby restaurants and things to do, basically in augmented reality view. As you move your phone around, the things that are in that direction will show, and the distance could also show. That was one. We made some augmented reality game prototypes, and we made some augmented reality applications also for like industrial use cases. So there were some companies at the time who were interested in exploring augmented reality applications for like virtual, what do you call it, portfolio. So if they have a magazine of their products, you can then point the phone at the magazine and it will like show a virtual version of that product. So this was all stuff I had done very early, 12, 13, 14, those kind of years. When the concept of augmented reality was pretty new, I would say. Not many people were aware of it, so it was very cool factor, right? And then in 2016, when I was graduating, we had to do what this like BTech project basically in our undergrad. So at that time, me and my colleagues who worked on this project, we made this application which allows you to draw a floor plan, which architects use or interior designers use, and then automatically convert that to 3D. So you just have to draw it and you will get the 3D version of that. Um, and in that project, one of the concerns I had or questions I had was like, how can I do that automatically? Like, why does the user have to draw this floor plan, right? It was more
Yeah.
like, I wish that I can just upload a floor plan image from somewhere and automatically be able to convert that to 3D. And of course, I knew it's possible because I had kind of seen, some applications which do maybe similar things, but I really had no idea how that's even possible. Right? I was just like, I know there's a way to do it. I just don't know like what that way is. I don't know what to search for on the internet. I just know like there must be some way to do it. And that's kind of how, the combination of doing some augmented reality stuff and then having this like project that I really was passionate about, but not really able to solve the way I wanted it to. These were the two things that fueled my interest in computer vision. Also, I was working on games, and I'm a very visual person, so I like to like see the outcome of what I'm working on. So it was just kind of, the combination of all these things really led me into this one direction. And then obviously, jumped a couple of jobs and did my master's. And during my master's, I really focused on machine learning and computer vision as my main goal. And then I kind of got a job after that in the field, and then I kept working, and now I'm at the company that I'm at.
Okay. So my next question is somewhat related to it, and I think you have almost answered it. Like, how are you so confident about the field? And while I was going through your LinkedIn profile, I discovered that you have been into mobile development, web development, and AR, obviously. And then you landed up to the computer vision. So, what motivated you to go towards this field?
So, kind of, I gave a bit of that in the previous section, but how was I confident about the field was more like I saw augmented reality very early, right? Like I said, whenever I used to show
Yeah.
anyone an augmented reality app, like imagine even today, right? When we use Snapchat or Instagram filters, like I think the first reaction is like, wow, that's so cool, right? Like people get excited. And we're in 2021. So I'm talking almost 10 years ago, right? Almost 10 years ago when I was making these apps, like you could see the reaction from people. Like they just don't believe it can happen. It exists, right? Like people are just like, how's that happening? Like, what are you doing? Like it's hard for people to imagine how good technology had become at the time. And so obviously there were difficulties, like all the AR Kit, AR Core, like these were the tools that Android and Android and iOS were, they just didn't exist at the time. So there was like a few companies far and in between who had some tools that you could experiment with. So I that was one reason, is like I really saw the potential in augmented reality as a platform. Um, Not just that, but coming to the second part is I tried web development, Android, iOS development. So I did all those things as well, game development. So I was a strong believer of like trying different things out because I didn't really know what I would have liked. So I had like an intuition that maybe I like, making games. So I definitely wanted to do that. But like the other things, mobile development, web development, those were things I just tried out. And for example, web development is something I gave a couple of shots at, but I realized like that's not something for me. So I have not developed any sort of web application for like many, many years because it's just like something whenever I start a project that involves like, HTML, CSS, JavaScript, I just like never finish it. So I realized kind of like that's just nothing, something I don't want to do. I actually enjoyed making mobile apps. Um, and then computer vision kind of just naturally flowed in over time, kind of, melding of my interests and curiosity, really.
Okay. Uh, my next question is, what skill does one need to possess to become a computer vision engineer?
Let's see. In terms of skills, well, you want to know basic programming, right? I mean, if you're pursuing a degree in computer science or related fields, then hopefully you have at least the basic programming knowledge required. Computer vision, and then maybe for the audience, I don't know if they're already kind of aware of the field, but I can maybe spend a minute or two explaining, first of all, what does this field involve, so that it's more obvious what skills are needed. So computer vision as a field, and there's kind of multiple ways people define it, but I think the easiest way to understand is like it's understanding what's happening inside of an image, right? So it's like if you use your eyes as cameras, then your eyes are just looking at something, but your brain is actually doing some processing to understand what's happening, right? I'm seeing you, I'm seeing, this like laptop, and I'm kind of making decisions based on that. Similarly, computer vision is nothing but saying that, okay, well, I don't have eyes, I have cameras. So now, using those cameras, now I need a brain to process whatever is happening in that image. That's kind of a simple way of putting it. So it's like the brain behind, looking at what's inside an image. And then you can extend that to videos, you can extend that to different types of sensors that are available now. So infrared sensors, like you might have seen, Microsoft Connect is very popular, right? So you stand in front of your TV and shake your hands, and
Hmm.
like it will detect what you're doing. So that's also like kind of infrared based. Sometimes there's other sensors known as LiDAR sensors, there's time of flight depth sensors, and so on. So, I mean, what originally was just for images now is extended to, different types of sensors, and really just understanding what's happening in a scene, right? So the scene could be, it's obviously the world, but it could be collected in the form of images. It could be collected just in the form of, 3D points, such as in LiDAR, which is used by a lot of self-driving car technology. So the LiDAR isn't scanning images per se. It's actually like very quickly rotating very, very fast. And it's collecting like points based on like shooting out rays of light. So that's kind of just another way of collecting input. But ultimately, once you have that like notion of the scene, then it's a question of, okay, like, is there a person in the scene, right? Are cars coming? How far is the car? Is there a traffic sign? If there's a traffic sign, what is it, red, yellow, green? These are the kind of questions that a car would want to know the answers to. Where's the lane? How far am I from the boundary of the lane, and so on. So this is just more about the field, but in terms of the skills that you would want to possess, then I would say first of all is, programming basic. Generally, a lot of computer vision programming is done in Python or C++, depending on kind of what you're doing. And then the next step would probably be to get some understanding of 3D geometry and math, because a lot of what we do is going from 2D, which is just an image, to 3D, right? Because you want to understand what's there. So you say, in this image, there's like a person, maybe he's this far, right? That's just one way. So 2D to 3D, we do a lot of 3D to 2D, and then 3D to camera. So you can even say, okay, well, I took an image from this camera, and then you have the 3D whatever coordinates of the person. Then you say, what if the camera was actually over here or over here somewhere else? And so how would this person look from this camera? And that's also useful for things like perspective correction, things like that. So a lot of 3D geometry and math, and this is something that you can learn as an undergrad student. You can take a course on it. The next thing would probably be a little bit of machine learning and deep learning. And though it's not required in the field of computer vision, right? It's good to know because nowadays a lot of computer vision problems are solved using deep learning. So it definitely helps to know that and have some foundational knowledge in that, because convolution neural networks have really been useful in solving computer vision problems. So if you know about that and how they work, that will help you. And let's see, and of course, if you can take a course, like if your university offers a course or you are able to take a course online about the field of computer vision itself, that's great, because it is a field, right? So there's different topics you want to talk about or learn about, such as camera calibration, which is one of the fundamental things in computer vision. Like if your camera isn't looking at what it's supposed to be looking at, like kind of all your math isn't going to work. So yeah, I think that would be sort of the skills you need. Of course, many of these things you can learn along the way as well. Like let's say you can start another way as well, which a lot of people do, is say, okay, I'm interested in this field, so let me go take a project in this field, and then I'll
Yeah.
figure it out from there. So that's the other way.
Uh, my next question is similar to what you answered. How should one start with computer vision, and what are some good projects to begin with?
Yeah, so the starting point, I would say, let's say you took some courses on basic things like some 3D geometry, a little bit of deep learning. But one I missed was image processing. There's also lots of universities offer courses on image processing. That's also very useful to know. So if let's say you took some basic courses and you have some understanding, there's I can't really pinpoint any specific beginner projects, but what I could suggest is the field of computer vision is very, very related to like solving real world problems, like problems that you can think about and you can envision, and then we can try to solve that using vision, right? Because it all ultimately involves cameras. So one way I think about it is like if you're a beginner in any field, you should pick a project which you actually have some sort of passion towards. For example, if you like using the face filters on Instagram a lot, then maybe you can try doing a project of rebuilding that, right? Like a simple version of the face filters algorithm. Like, how is that even happening? So once you start searching for that, like how to implement face filter, you'll come across lots of different uh, computer vision and also computer graphics uh, kind of algorithms that you need to implement, and then you work backwards from there. So that's kind of my approach. Another way might be you say, I'm interested in, implementing augmented reality. Like I want to make some library from scratch where I can do augmented reality. Then you have to say, okay, well, what do other augmented realities, implementations do? So then you go and you work backwards from there. And so you'll realize you have to do things like first you have to, do like scene understanding. You have to do, what's it called? Localization, mapping. You have to really understand where you are in that 3D scene and so on. Um, yeah, that's kind of one way is work backwards. The other way is you can go online and search for open source projects that are available. So there's this library called OpenCV, which is kind of open computer vision. It's a very core and fundamental library to anyone that does computer vision. And so you can go to OpenCV's website and start from the basic tutorials, and they teach you different topics, starting from the basics of computer vision. It's very kind of, they hold your hand. And that's one way. There's also lots of like tutorials that you can do, which will teach you, how to do blah, blah, blah project from start to finish. And then you can kind of follow their tutorial. And along the way, if you don't understand anything, you can go and learn more about that through reading or whatever.
Yeah, I think the computer field is all about it. It's just exploring, learning, and then exploring.
Yeah.
Okay. So the next question is how to prepare for internships and placements in the development field.
So by development field here, do you mean like software development in general?
Development is like computer vision and Android development or web development. Okay. Like leaving software engineering apart.
Hmm. Well, I would say they're very related, right? Like all of these are subfields of being a software engineer. So I don't, in my mind, there's no difference between software engineering and any of these fields. So I'll just kind of give you my general thoughts on these. So the first thing to prepare, obviously, which most people would be aware about, is there's like these competitive coding type of questions that
Yeah.
companies ask. It's more like, I would say it's a combination of just like trivia plus understanding how quick you can think, and then just like understanding some core concepts of computer science. So that's like the number one most important thing that you should do to prepare for yourself for answering these kind of questions. And then specifically, right, if you're targeting web development roles or Android development roles, then you need to know the fundamentals of those, ecosystems, right? So as an Android developer, they might ask you like, what is an activity? What is a fragment? How would you go about building blah, blah, blah type of app using whatever basic Android frameworks are available? And you should be able to answer those questions. As an intern, obviously the expectations are a little lower as compared to full time. But the idea is that if you're applying to some specific subfield, you either already know a bit about it, or you're like really, really passionate and want to learn that on the job, and but then your core skills are really strong. Same goes for computer vision, machine learning, kind of. You have to know how to solve these like competitive type questions because everyone just asks them. And then you also have to have the specific knowledge of that field.
Okay. The next question is, how can one get to know about the opportunities present in the development field?
Cool. That's a great question. I think first and foremost is through your university, wherever you're studying, right? You should hold them accountable to give you access to opportunities. And if they don't have access to opportunities, then it's I believe partly the student's job to help them get that access. So use your personal networks, try to join the training and placement cell, become a coordinator, or at least talk to the coordinators, whoever's volunteered to be one, and try to help them get more companies to come and talk to people at your university. Obviously, companies are always hiring, so they're just always looking for better candidate pools to reach out to. And if you can convince a company that your college or university has good students, then it's win-win for everyone. So let's say, but you're looking for example, computer vision opportunities, and your university doesn't have any companies that are specifically hiring for these type of opportunities, right? Maybe they have tons and tons of generic software engineering or backend or like Android roles, but they don't have anything related to computer vision, which is possible, and like that's still okay from your university's perspective. Um, so what I would say is in that case, then you want to follow the next steps, which is reach out yourself, right? First of all, find out which companies are hiring for that role at your level of experience. So you might be a new graduate, you might be looking for an internship, so you're still a student, but find out which companies are hiring for those type of roles. And for this, you can use LinkedIn, you can use, whatever job search platform that you have available to you, and start looking for the keywords that that are required in that industry or that field. So once you've kind of targeted those roles, so let's say you found like 10 companies that are hiring for computer vision, which are, like I said, just use online job search platforms. After that, you can then start applying either by first building up your portfolio to showcase those skills. If you don't have them, that's required for the job. And if you already have them, then it kind of come down to your resume, building your LinkedIn project portfolio and things like that, so that when you do apply to those companies, you've already shown like a strong backbone, and then it's just about the interview process.
Also, I think like there should be a tribe in your college who's focused on this. Otherwise, why would company come for just a single child?
That's true. That's an interesting point. When I was in college, social media wasn't, LinkedIn, nobody used LinkedIn. Like I made my LinkedIn profile after I graduated. Um, so there wasn't really a focus at that time on, community, or like there wasn't Discord, there weren't so many, groups trying to do these kind of events online. Live streaming wasn't a thing. So it's an interesting point you brought up, but when I was a student, that was just like no one ever talked about these things. It was just like
Yeah.
there was like one development club in college, and then maybe there was like a ham radio club, and there were like some clubs that were ongoing for many many years, like robotics club. And so like if you're interested in one of those things, it's fine. But like nowadays I see the trend has changed, where like, yeah, you're right, there should be a tribe, and if there isn't one, you're encouraged to go create it. And then you can obviously access resources through the internet, through YouTube. You can watch tons of videos. You can like reach out to people in the field through LinkedIn. But yeah, that those resources weren't available at my time.
Yeah. Okay.
Or even
So the
if they
next
were, I
question.
would say like, sorry, I was saying, even if they were
That's
available,
okay.
like at least I wasn't smart enough to use them, and I don't think the people around me were either, because no one told me about them.
But that's a very long back now. It has moved forward, and one should. I personally, I feel that one should have a tribe. Your tribe motivates you further.
Definitely, that's a good thing.
Yeah. So the next question is like, what are the subfields available in the domain?
Definitely. So computer vision is a pretty large, vast field. And once you get into it, kind of, there's so many different areas that one could go into. So I think this is a great question. To start with is the basics, right? Is like cameras. You can just be working on cameras for like many years. That means like I mentioned this word before, but camera calibration, which means kind of making sure the camera is actually, seeing what it's supposed to be seeing. And then if you have multiple cameras, right, you want to make sure that, let's say two cameras are next to each other, then they both need to look at the same kind of parallelly to each other, because that helps you get some interesting properties of cameras and vision, which I won't go into the details. But what you don't want is that they're next to each other physically, but they're actually looking in like slightly opposite directions, something like that, or like that, which happens because, it's a very like basic problem. But when in the factory, when you make the camera, or let's say a cell phone, you're sticking the camera to the phone, it's actually like glued on. So the glue may not be even on across, right? Like there might be like 0.01 millimeter more glue on one side than the other. So that can cause like a slight misalignment. And then inherently, like the lenses you use, they're not perfect. So there's some imperfection. So you have to correct for these kind of things. So always like cameras is one field that, it's always going to be there, because there's new types of cameras, new configurations of cameras. There's like liquid based cameras or something now, and I've heard all sorts of things. Um, so that's like one area that people focus on. The other could be augmented reality, which obviously, is very popular nowadays. So there's lots of fundamental computer vision technologies in augmented reality. There's also technologies related to implementations of augmented reality, or I mean like applications built on top of augmented reality. Um, that's another. Another is of course self-driving car technology, which is a very big use case for computer vision. So it's kind of, your car needs to see around you. So that's one area. The other is robotics. So even in the robotics field, you need your robot to see whatever it's, supposed to be looking. So if you've seen those robots that like, grab an object, place it somewhere, grab an object, place it somewhere. Um, People are trying to make even those robots smarter and use vision technologies. There's also like actual smart robots. So if you've seen the Roomba iRobot, which like cleans your floor. A lot of people here in the US have it. So you just like turn it on and it will go and clean your whole floor. And it will even like avoid obstacles. So if you're standing in the way, it will move around you. If you have like a cat or dog, it will, like not hit the dog. It will just go around it. Um, and over time, it actually learns the map of your floor. So in your phone, in the app, you see your home's map, and you can tell it later like, okay, go clean only this part of my house, and it will go and clean it. So that also uses computer vision, lots of localization mapping, things like that. What else? I think these are some major like use cases for vision. Um, Images, right? Improving the quality of images is another. So if you've seen portrait mode on the phone, Google does a lot of work in relighting images. So that's another one. Panorama shots, if you ever did that on your phone, those are all like related to computer vision.
Okay. So the next question is like, any tips for resume building and what headlines should one cover?
Let's see, what headlines should one cover. So in terms of resume building, this is something that, apart from helping people out, just understanding about the basics of the field, I do kind of, I'm a big believer of having a strong resume and portraying whatever it is that you've done in a very strong way. To start with, I would say, use one of the tried and tested templates. So there's a great template that I can share. Uh, it's by FangPath, so you can just basically use that template. It's available online for free. I think the URL is like fangpath.com/template, and so that's a free template one can use, and I use a similar template to that as well. So basically, single column, very straightforward, no colors, no images, no fancy text. It's just really like Times New Roman font and top section, 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 section. Um, that's kind of the number one. Like if you do that, you kind of are 50% of the way there, because you're already beating all the students who like put their image or put their like 10 standard marks on their resume, which is not required. But yeah, I would say start with that template, right? And then from there you want to really like showcase how you fit the job description, right? So if you're applying for a computer vision engineer, even if you don't have computer vision experience because you're a student or you never did it professionally, like make sure you can show how you fit that role. So you say, well, hey, I didn't do computer vision as an experience, but I did this computer graphics project. I did this project which I had to use some augmented reality library, or I took a course in image processing. And you have to like show these different things, and then tell a story about, like, in your summary section, tell us why you're applying for this role. I would say, as a reader of a resume, the other person, they need to really understand why you've applied for that role, and like, would it even make sense to hire you, right? And this is less so for like on-campus hiring. If it's on campus, kind of they'll just interview everyone, and then whoever does the best wins. But this is more like offline, and I would say computer vision, people generally don't hire for these kind of roles on campus. So if you're really interested in this field, then you kind of want to go the other route and make sure you have a strong resume.
Yeah, definitely. I think we are done with the questions. We'll take up now with the questions from the audience. Okay.
Awesome.
So Rohan asked, can you say some resources to learn computer vision if I'm beginner and no basic ML algo?
Yeah, so Rohan, I hopefully we answered your question, but one resource is the OpenCV library. So they have a lot of good tools for computer vision in terms of already implemented basic algorithms. But they also have great tutorials. So that's one resource. I would say, look online. There's this great course by Georgia Tech, which is a university in the US. They have a free course on Udemy or Udacity or one of those websites. I don't remember which one, but that's also a great starting point if you want to take a course online. Those are some resources, and then you already know basic machine learning, so that's great. You have some math background.
Okay. The next one is from Bhagal. He says
Mhm.
your view about Julia language.
Julia language. I have never heard about this language, so my view is that I have no view about this language.
It has
Um,
recently come, and even I don't know. I just know the name.
yeah, I'm just looking up online. Julia, high performance, multiple platforms, scientific computing. Unfortunately, I don't know enough about this, but if it's recently becoming popular, it's probably good.
Okay. So Ishan is asking, how deeply did you need to understand the math? How did you go about learning the math? Was it something that was easy for you?
Great to see Ishan here. I've done multiple weeks of mentoring with Ishan. So nice to see you,
Oh,
Ishan, in the comments. But how deeply do we need to understand the math, and how did you go about learning the math? Was that something easy for you? So I would say you need to understand the basic, algebra, geometry pretty well. It doesn't depends on your day to day, right? And this is something we didn't talk about in this particular talk, but in the industry, right, there's multiple types of roles. So there's like research roles where you're basically your job is to research and find fundamentally new ways of doing something. So that would involve more and more math because the only way to like make fundamental breakthroughs is by knowing all the existing fundamentals very well, which are all math heavy, and then like trying to improve them. Also, if you're doing like deep learning, which is what researchers would often do, then there's quite a bit of math involved if you're trying to like make something new or propose a new loss function, things like that. Um, for me personally, I know all the basic math. I'm not very I won't say like I remember all the formulas at the back of my mind, but I have a basic understanding of all the different fundamental math things required, and then if I need to, I can look it up as well, refresh myself. And if it was easy for me, not at all. Actually, during undergrad when I was studying, I actually there so we had in my school like three math courses, M1, M2, M3. Like one was calculus, one was algebra. I don't remember what the third one was. But so I always thought like I would never need this in my life. So I really never paid attention to either of those classes. So because no one ever told me that you actually need to use this if you're trying to get into these kind of fields. So, and that was in my first year and kind of like first semester of the second year. So I never paid attention to those classes. I was just like, yeah, whatever. Like it's just a repeat of some of 11th, 12th stuff. And yeah, I was more focused on like building apps and games and whatever. So I was just like, yeah, I don't need any of this stuff. Turns out you do need it. So if you are interested in this field, then I would really strongly suggest to pay attention in those classes. Um, and yeah, that's kind of what I would suggest. But for me, it wasn't easy because I never paid attention in those classes. And then when I realized that I need to actually use these things in my day to day, then I had to like go back and relearn or like re-understand a lot of the fundamentals.
Okay, I hope it answers. Now, next question is from Aman. He asks, do you professional guys code using OpenCV, open source, or use some commercial library?
So I would say OpenCV is a very good library. It's open source, and um, in some of the jobs I've worked at, we've used OpenCV like every time. Um, in terms of commercial libraries, I can't think of any at the moment, but OpenCV also has, I believe, a way to use commercial functions and tools in OpenCV. So some of the algorithms are actually, like patented or protected. And so OpenCV has a way to use them. But I've never explored how that path is, but I know it's there. But yeah, OpenCV is great. It's like a very kind of fundamental tool in your pocket as a computer vision person. So yeah.
Okay, again, he asks, which is the most popular language for this?
Yeah, so as I previously mentioned, mostly Python and C++ are the main languages in this particular domain. Another one that people use less often nowadays is MATLAB. Previously, when Python was not so popular, a lot of computer vision was happening, or computer vision exploration was happening in MATLAB. So that's the third one. But if you're starting today, I would say start with Python and only use C++ if you actually need to, because whatever you can do in C++, you can also do in Python. It just might not be as efficient or fast or like work on device the way you want it to, but for learning, for experimentation, Python is more than enough.
Okay, Pallavi is asking, I'm interested in knowing about the testing of the augmented reality apps. Could you please throw some light how to test it? What are some challenges when you test it?
Hmm. So I've never tested augmented reality apps professionally, but I have tested, projects that I've built that were related to augmented reality. So I can talk about how I tested my projects and the things we looked for because based on my experience, I would say obviously a lot of the testing is really like you're like load some app into your phone which you've made, and then you like start opening the camera, and then you basically look at the result. You want to try things like, for example, if you're trying to detect like a QR code, then you want to manually start covering parts of the QR code with your fingers, or like put two QR codes next to each other. Really, it's like it's the same way you would test anything else, right? You just try to break it. And in augmented reality apps, the way to try to break it is like you understand the assumptions the app has, or the technology has. So if it's like a QR code, it's assuming to find a QR code. But then you want to see, what if it finds four QR codes? What does it do then? Or can it even look for four QR codes? Or like, was it supposed to detect all four, or is it supposed to detect any one? So just, it's similar to like testing in general. You ask questions of like, what if this, what if that, and then you try to answer them. And just a lot of it, the only difference is really you're like running a camera on your phone or on some device, and then you're just trying to like, whatever it is supposed to look for has to be in that view. So I would say sometimes it gets a little annoying as well. Like every time you want to test, like for example, if you're doing uh, one of the augmented reality apps I was doing involved like scanning the floor and building some 3D virtual scene on the floor. So every time I had to test, I had to like stand up, scan the floor, and I needed at least 10 feet. So I had to like scan 10 feet worth of floor every time. So it gets a little annoying, but that's kind of the only difference than any other type of testing.
Okay. Pallavi's question is again related to it. Like, what are the some topics in AR we should know before testing?
Hmm. I don't know for testing if you need to know about topics specifically. I guess as long as you know what is augmented reality, what is the goal, right? And then for the specific algorithm you're working for, like what is it trying to do? So if it's like I said, a floor detection algorithm, you want to know that it's trying to actually detect the floor. If it so then that way you can test around that. If it's like a face detection for the what is it called, the face filters, then you would like to know in advance that this algorithm is trying to find a person's face. So then you can break it, right? And the obvious ways are like, what if this person has a huge mustache? What if this person is wearing glasses? What if they're wearing a hat, goggles, things like that? How does that break the algorithm? Um, and I'm talking more right now about manual testing, but there's also like large scale testing, right? Which is the algorithms themselves. You can train them on like large sets of data available online. So it doesn't need to be a live camera feed, right? It can be on images that you've pre-selected, or a video that you've like pre-collected. So you can try on different types of things. So for example, floor detection, like try it on carpet, try it on wood, try it on tiles, try it on like dirt, try it on whatever else you can, like grass, right? Like it should still work, hopefully. And then if it doesn't work, you have to go back to the team and say like, okay, well, we tried on like 10,000 samples of grass, and it works only in like 3,000 of those cases. So large scale testing is also the other one.
Now, Amina is asking, what libraries do you use, sir, at workplace or professionally?
Yeah, I think one of the libraries we already discussed is OpenCV. If you're doing Python, generally a library you might use is NumPy. Um, you might use Matplotlib, which is another open source library for drawing plots and images. Um, you might use Pandas, which is another library in Python for reading data frames. So really, all of the difference there's really no huge difference between what you would learn or use academically versus professionally in terms of the libraries. The only difference might be that the company that you're working for has their own set of libraries that they've created over time to solve specific problems or work with their ecosystem. But if you're learning some library as a student, then you can very well expect that that library would be used professionally as well.
Again, he's asking, how can we as undergrads start working on any AR project, any resources?
So if you're looking to use augmented reality, like just as a developer, as an app developer, and not like build augmented reality technology, then I would say you can start with Android and iOS. Basically, they have very good tools available. It's like within a few lines of code, you can basically get started with an augmented reality project. And then I would follow tutorials related to that. So if you're using an Android phone right now, just Google how to use AR Core. And it's like maybe 10, 20 lines of code to have some beginner project. And then from there, you can, as you get more creative, you can start figuring out how to move from there.
I think we are almost done with the questions. Uh,
Awesome.
Yes, it's great to see you. And the audience, if you have any more questions left, you can ask now. We are just wrapping up the session. And Aman is also saying great session. And sorry.
Thank
And
you, Evan.
again, we have another question. What are good online resources to learn about camera geometry and mathematics required for computer vision?
Hmm. I'm trying to think, where did I learn this? I would say definitely try the course by Georgia Tech. That's pretty good in learning camera geometry. For the mathematics part, um, for the mathematics part, um, I would say you just kind of have to learn from like either your university courses or look for like, geometry or algebra courses online and see what you can find.
Ishan is asking, since you have done some work on pedestrian safety, what is your thought on vision versus LiDAR for self-driving?
Vision versus LiDAR. Let's see. I guess you mean cameras versus LiDAR, but um, both has its pros and cons. I think Tesla is a great example of obviously showing and proving that you don't need LiDAR. You can get away with only cameras. And so personally, I feel like that's the way to go because humans, right? We as humans, we don't have LiDAR. We just use our eyes, which are essentially cameras. Actually, a combination of eyes and mirrors because we cannot see behind us, so we use mirrors. But all of us as humans, we can drive using just our two eyes plus a few mirrors, which essentially is, in my mind and other people as well who believe in cameras, proof per se that that's all you need to drive. Um, and so, like I said, Tesla does that. So I personally think that's the way to go, but I can see the advantages of LiDAR as well, which is like it's reliable, right? You're always getting that mapping of the scene. You put like 5 LiDARs on your car and you're like getting a pretty reliable 3D map of the scene. It's fast. You don't really need like, and maybe you do, but you don't need like crazy GPUs running in the car to kind of get that data. It's more about then how do you just process the LiDAR data. So I would say um, there's definitely been a lot of work with LiDARs, but in my mind, the cameras will eventually prevail.
Okay. Next question is again by Aman. Are there any open source organizations to have experience with computer vision and AI?
I don't even know what that question means.
Like I think like any open source projects we can contribute to.
Okay, so you can contribute to OpenCV, right? It's on GitHub. You can contribute to it. I've contributed to some of the deep learning libraries. More so, like there's one for this YOLO, which is you only look once, which is for object detection. there was some bug in one of their tools, so I had contributed personally to that library because I was trying to use the tool and it wasn't working. So with a specific version of Python, so I added like a line or two. So if you're like using some open source library and framework and you have difficulty, then I would suggest that you can contribute to that. And then I would say just go to GitHub, right? Search for computer vision, see what the top projects are, and then click on them one by one. Look at the open issues, see if they have contributed in guidelines, and if you want, you can start contributing to those repos. That would be the, I guess, best foolproof way.
Okay. Now, again, last great presentation.
Thank you.
I'll just add the link to Puneet's LinkedIn over here. So if anybody wants to connect with him, they can. And then we'll wrap up. Thank you so much, sir, for such an informative session. I hope our audience gained a lot.
Of course, thank you for having me.
Okay.
Right. Bye-bye.
Then we'll end.